For the triangle midsegment coordinate proof, we're going to go through and use a coordinate proof to verify that DE is parallel to AB, so this midsegment is parallel to the side, and that it's half the length. DE is half the length of AB, given our vertices for A, B, and C. So we start off, we need to use the midpoint formula to find the coordinates of D and E. So midpoint of point D is going to be the average of the x values and the average of the y values. So D is on AC, so our x values are 4 and 0. Our y values are 6 and 0. This gives us a coordinate of 4 over 2, 6 over 2, which is 2, 3. And if we look, we kind of see we went over 2, up 3. That's our coordinate there. Now for the midpoint of E, we're going to take our x values, which is 6 plus 0 over 2, 6 and 0. And then our y values are 0 plus 0 over 2. So we get 6 over 2 and 0, 3, 0 is our coordinate here. Now we probably could have checked and looked at the graph and seen that, but it's good that we do confirm it with the midpoint formula. So now we need to show that the midsegment DE, this line, is parallel to side AB, and we're going to use that with slope. So we're going to find the slope of AB. So I'm going to write MAB and then MDE, using the name of the segment as the subscript. So the slope for AB. Now slope, we have to remember, is change in y over change in x. That's y2 minus y1 over x2 minus x1, or we could just do the difference of those y values over the difference of the x values. So from A to B, I went from 6 to 0. So 6 minus 0, and I went from 4 to 6, 4 minus 6. Should have written this on AB. We'll change that. That's AB now. So that gives us the top of 6 over negative 2, which comes out to be a negative 3 slope, which we could check. It went down 3 over 1, so it even appears that on the graph. Slope formula confirms that. For DE, we went from 3 to 0, so 3 minus 0, 2 minus 3, and that comes out to be 3 over negative 1, which is also negative 3. So that tells us, because the slope of AB is equal to the slope of DE, which is equal to negative 3, therefore DE is parallel to AB. Now our last step is we have to show that the length of DE, the length of the midsegment, is half the length of AB. To do that, we're going to use a distance formula. Another way we can remember distance formula is it is the square root of the change in x squared plus the change in y squared. So it's that difference between the two. So let's find the length of DE first. So in DE, our change in x's are 2 to 3. So that means it's a difference. We could do 2 minus 3 squared. Change in y's are 3 to 0. 3 minus 0 squared. So this becomes the square root of negative 1 squared plus 3 squared. And if we look, that's how much the x has changed and how much the y has changed. So now when we square them, we get 1 plus 9, which is the square root of 10. So our AB, we're going to do 4 and 6, so that difference is 6 minus 4 squared, and then 6 minus 0 squared. So we have 2 squared plus 6 squared, which gives us 4 plus 36, which is the square root of 40, which at first look makes it almost look 4 times the amount, but we have to remember to simplify the radical. Because 40 is 4 times 10, I can take out the set of 2's, or I can take the square root of 4, and that becomes 2 root 10. So this shows us that DE is equal to 1/2 AB, because square root of 10 is equal to 1/2 2 root 10, which is also root 10. So this shows, this was a proof using the coordinate that the midsegment is half the length of the side and it is parallel to the side when we draw a midsegment from midpoints.